Institute of Technology 1.5 years from 2004 to 2005, and she worked as an assistant professor in Anand Institute of Higher Technology from 2006 to 2009, and right now she is promoted as an associate professor in Anand Institute of Higher Technology from 2011 to till now. She is having the industry collaborative work also she is doing, technical consultant in the Fleet Motors Private Limited from 2019 to till date. And she is having a project ongoing works also, DST seed from 2021 to 2024, AICTC project she is having in from up to 2025, and DST NCSTC she is completed from 21 to 22. Several online courses also she completed, and international journal publication, 2 international journal publication she had, and 3 IEEE conference publication already had, and international conference publication is having 2. By this introduction, I am welcoming Engineer Aruna for starting the technical talk. Engineer Aruna, please. Yes, madam, please.
Sir, my screen is visible, sir?
Screen is visible. Shared. Screen shared.
Okay, sir. Okay, sir. Thank you.
Your voice is also audible.
Okay, sir. So, good evening to one and all present here. First of all, I would like to express my heartfelt thanks to the chairman of IEI, KLC Kalpakam Division, Mr. M. Shanmugasundaram, sir, our management and principal of Anand Institute of Higher Technology for giving me an opportunity in this Technology Day Talks 2023 to deliver a lecture on recent advancements in EV technologies. So we know already about the parts of EV. So in this about the parts of the EV, we are going to see about the technology innovations in batteries, chargers, and then powertrain components. So these are the main topics I'm going to cover in this lecture, and also I'm going to cover about the autonomous driving. So these are the presentation contents: battery technology innovations, charging infrastructure development, battery swapping technologies, electric motor and powertrain innovations, autonomous driving, softwares used in EV, and what are the opportunities in EV industries. So first, we are going to see about the battery technology innovations. So in the battery technology innovations, it encompasses the advancements in various aspects like their chemistry, performance, capacity, charging speed, and overall efficiency. So here are some notable battery technology innovations. So the first one is nanobolt lithium tungsten battery. So this is a new and advanced improvement to current lithium battery technology. So these revolutionary batteries are targeted at the industries as well as the in electric vehicle market. So these batteries are enhanced with the addition of tungsten and carbon nanotubes to the anode section, which increases the battery's ability to charge more quickly and to hold a charge for much longer. Then, when seeing about the sodium ion batteries, so these sodium ion batteries are a relatively new battery technology and which uses the sodium ions instead of lithium ions to store and convert energy. So these batteries offer a low cost, high safety, and long cycle life. However, they have a low energy density and they are still in development phase. So the sodium ion batteries, these are considered as an alternative to lithium ion batteries for large scale renewable energy storage and electric vehicles. Then on seeing about the metal hydride batteries, so they are newer and more efficient alternative to lithium ion batteries. So they offer higher energy density, longer cycle life, and less toxic. However, they are still they are less efficient than lithium ion batteries, and these batteries are also in development phase. So on seeing about the salt water batteries, so this is one of the advanced EV battery technologies in 2023, and since the name salt water battery, the list it has a concentrated saline solution as its electrodes. So describing its function, the water molecules will pull the sodium and chloride ions apart, making them free floating. Then the sodium will be extracted from the solution while charging the battery, and the extracted salt water is discharged with oxygen dissolved in it. This acts as an oxygen to produce electricity. Unlike conventional lithium ion batteries, these batteries do not use any flammable electrolytes, thus making them much safer and easier to manufacture, use, and recycle. So these batteries can be recharged for more than 5,000 cycles during their lifespan. And since they are typically inflammable and non-explosive, we may say that these batteries will be used. It can be used as an alternative to the lithium-ion batteries. So, what are the trends shaping the future of the battery material market? The first one is the development of solid-state electrolytes. So, traditionally, the battery electrodes are connected with the liquid electrolytes, which makes it difficult to reduce the weight and size of the battery. So, we can use the solid electrolytes, which increases the capacity and voltage of the cell. So, the liquid, when we are seeing about the liquid electrolyte in lithium-ion batteries, they are flammable, and when the cell temperature heats above 80 degrees centigrade, it results in explosion. Solid electrolytes have been developed for next generation batteries to overcome the challenges of the conventional batteries. Then ultra fast carbon electrode. So this is they use the vertically aligned carbon nanotubes design, and they boost the battery power by tenfold, increase the energy storage by a factor of 3, and increase the life cycle by a factor of uh, uh, fivefold. So the primary beneficiary of this electrode is EV, as it reduces the carbon footprint and the cost of the battery production. So already, when we are already we have seen about the sodium ion battery materials as well as the nanobolt lithium tungsten batteries. So next the topic is charging infrastructure development. So the electric vehicle charging infrastructure faces numerous challenges in terms of development. So why it is challenging? Because due to the high initial investment. Because this that is to set up a EV charging infrastructure, some requirements need to be fulfilled. So the like proper location, land, right vendor, grid power stability, remittance of power, varieties of charger types, cables, and other aspects. To the high cost of setting the EV charging station, the only way to make fast charging station feasible is to increase their utilization. So for that, the charging infrastructure should be set with the DC charging, which is more useful than the AC charging technology. When we are using the DC charging, we can directly use the charger, but when we are using the AC charging technology, we have to use the converter to convert AC to DC. Even the government also needs help for setting the charging infrastructure by investing with EV companies. So there are several connectors are there, type 1, type 2, CCS, Compo T1, T2, Tesla, Caremo. This is a Tesla, it can be used for the Tesla cars. Then GPT-AC, GPT-DC, Kyoji. These are the several charging connectors, and these charging connectors should be available in a single EV charging station. So that is the main difficult task that should be overcome now. And so as the infrastructure is being developed day by day, we can say that the EV charging stations, it will be already India is having many EV charging stations, but the feasibility is very less. Now they are in the market now. Many companies are in the race to increase the feasibility and the utilization. So when the electric vehicle usage is greater, the EV charging station usage also will be greater. So by that we can say that this infrastructure facility also will be feasible. So the challenges are high initial investment, the location, technical safety, as well as the software related changes. So EVs, they will be offering the sustainable solution. So with the growing support from the government and the increasing awareness, so electric vehicles are certainly the future of automation. Then battery swapping technology. So we may hear a lot about the battery swapping technology. So this battery swapping technology is not developed now. It was developed in the earlier period, that is during the 18th century, and then from the 18th century it is from the 19th century, it is increased day by day, and then finally now it has come into a full picture. So the battery swapping technology. So in the historical period, in the earlier days, when we use the horses, to travel from one place to another. So since the animals, they have they have limited range of travel due to their biological and physical constraints. So the arrangements have made at regular intervals in that earlier times to swap the horses. So similarly, in 1914 to 1922, a Milben Bergen company. It was founded in 1848 in Toledo. It is in Ohio, which was one of the more successful electric car makers of those time. So in 1915, they introduced the battery swap out system, which had batteries on rollers, so that allowed the owner to roll out the discharge batteries and to roll in the charge ones. So these are the battery swapping technology. So the Mercedes, they have tried the battery swap in the earlier in the 70s, that is 1970s. So in 1959, we can see that these are the several cars which can use the battery swapping technology. That is in 1959, the Henry kilowatt made its appearance in the United States, and it is designed by the National Union Electric Corporation. In 1966, GM's Electrovire 2, they have used the battery swapping technology. So the battery swapping technology, it has been increased. That is, the development has been done from the 19th century, and now it has come into a full phase. So these are the battery swapping technologies as of now. So these are the battery swapping stations. So many companies, this Sun Mobilities, these companies are in, that is Gogoro, Geely, and Better Place. These are in China, and the Sun Mobility swap points are available in India. So since the some of the constraints are there in battery swapping technologies, so many researchers are going on in this technologies also. When we are seeing about the electrified powertrain, so this electrified powertrain, the Nissan company, it is continuously they have given a new approach to the powertrain. So first they have developed 3-in-1 for EV, and then 5-in-1 for e-power. So 3-in-1 is nothing but it will be modularizing the motor, inverter, and reducer. Reducer is nothing but this device that decelerates the output, the rotational speed, yes, and also they can output torque inversely proportional to the deceleration. So that is, they multiply torque and reduces the speed in order to reduce the overall cost of the EV. So in the 5-in-1 for EV, it is modularizing the motor, inverter, and reducer in addition to the generator and increaser. So increaser is nothing but increasing the range. So by using the regenerative braking, we can increase the range of the. So this X-in-1 approach, it is improving the production efficiency and it reduces the powertrain cost by approximately 30%. So the size and the weight of the size and weight of the unit is also improved, and that is it is reduced, and then the cost is also reduced. So by that we can have the X-in-1 approach. Then when we are seeing about the motors, so there are different types of motors are used. So they are using all-in-wheel drive, then two-wheel drive, then they are giving more advancements in the motor technologies. So among those axial flux motors, they have power density above 6 kilowatt per kilogram, and they have still have good efficiencies. So this adoption of the adoption of axial flux motors, they are expected to witness a huge growth in coming years, especially in performance wise. Then when we are seeing about the in-wheel motors, so the in-wheel motor will have a direct drive mechanism. So they can be either radial motor or axial motor. So in this in-wheel motors, so all the motors, brake disc, and then brake caliper, suspension spring, suspension active integrate, so everything is present within the wheel, so which is reducing the size. So and then when we are seeing about the switch reluctance motor, the already many researchers are going on in regarding the motors. So we have and the Tesla cars, they are using the induction motors, and now they are slowly switching over to the synchronous reluctance motors. And then some of the many of the cars, they were using the permanent magnet motors, PMSM, that is permanent magnet synchronous motors. But due to the rare availability of the permanent magnets, that is rare earth magnets, so they are slowly shifting over to the switch reluctance motors. So the switch reluctance motor, it is an emerging alternative for the e-mobility applications because of the absence of the rare earth magnets, and also due to the advancements in power electronics and IoT. So we can have the switch reluctance motor also can be seen as an alternative to the existing motors of EV. So this is the e-axle. It is one of the most advanced 3D printed electric motors. So its ampere is 220 e-axle. So it includes all the power electronics, silicon carbide inverter, and integrated transmission system. So that directly powers the vehicle axle. So the peak power is about 220 kilowatt, and the maximum motor speed is about 30,000 RPM. So the weight is under 20 kg, and it offers power density of 11 kilowatt. So this is the most advanced 3D printed electric motors, because now due to the invention of the 3D printers, so the 3D printing technologies were used in every machineries. So this is one of the e-axle is one of the 3D printed electric motors. Another one is the trapezoidal stator radial flux permanent magnet. So this is the smaller, lighter, lower cost motor, especially for two-wheelers as well as the three-wheelers. Then another important advancement in motors is Octopus. Octopus is nothing but it is the optimized components, test, and simulation toolkits for powertrains, which integrate ultra high-speed motor solutions. So this Octopus, it will take this leading. It is a leading edge motor, power electronics, and packaging transmission design, adding next generation materials, manufacturing process, simulation, and test cycle to deliver a full e-axle powertrain with unique levels of integration and revolutionary performance, and which is suitable for real world application by 2026. So when we are seeing about the advancements in the power electronics, so silicon carbide MOSFETs, they are used as the wired backup devices, and this is where it is more favorable to the EV industry. So silicon carbide MOSFETs, they have the lower switching and conduction losses when compared to the silicon IGBTs and MOSFETs. So this lower switching losses and conduction losses, it is very essential to increase the mileage of the TVs. So similarly, silicon carbide based switching devices, they have the higher junction temperature of 175 degrees centigrade when compared to the 150 degrees centigrade for silicon based devices. So thus we can design an integrated powertrain with the reduced cooling requirement. So in addition to the high switching frequency silicon carbide based devices, it reduces the passive size of the passive components like DC link capacitor, boost inductor, and EMI filter. So these features of silicon carbide semiconductor devices enable the reduction of overall size of the powertrain, which indirectly achieves the high power density in EV. Then automated mobility. So we are continuously hearing about the self-driving cars. So the self-driving cars, they are first introduced by the Tesla, and it is the usage is increasing day by day. So automated mobility. So what is automated mobility? So it can be divided into five categories, five technology levels. So first one is level 0. Level 0 is also known as everyday car. So it is a normal car, and the driver has to perform all the actions of driving, steering, accelerating, and braking, and the vehicle will not be having any autonomous or self-driving functions. So when we are seeing about the driver level 1, so it is also known as driver assistance or hands-on. So here in this level, it is having ADAS. ADAS is nothing but advanced driver assistance systems. So with the ADAS on the vehicle will be assisting the human driver with the either steering or braking or accelerating, but not both simultaneously. So that is known as level 1. Level 2 is known as partial automation or hands off. So here the ADAS will control both steering and accelerating simultaneously under some circumstances. So the human has to continue to pay full attention at all times and perform the rest of the driving task. That's the partially automated. Then level 3, it is the conditional automation. So ADAS on the vehicle will be performing all aspects of the driving task under some circumstances. In these circumstances, the driver has to, he should be ready to take back control at any time. Level 4, it is also known as high automation, or we can say that it is minds off. So ADAS, it will be performing all tasks and monitoring the driving environment essentially, and do all the driving in certain circumstances. So the driver need not pay attention. So the driver, they can use a mobile, or they can do whatever he needs. They need not pay full attention to the level 4 part of the autonomous vehicles. In level 5, so there is no occupant in the vehicle. It is known as body off. So it can do driving in all circumstances under the control of AI. So here in level 5 full automation, uh, artificial intelligence is used to perform the driving under all circumstances. So these are the five types of control. So in the autonomous driving, what are the key building blocks means? Sensing, detection, perception, and precision. So in the sensing, intelligent sensors should be used to see, feel, and sense the surroundings. In detection, we have to detect the objects such as vehicles, road lanes, people, traffic signs, and whether it is in en route or not. We have to classify that. So that is the detection. Perception, so real-time information for localization and path planning. So we have to plan for the path. Then decision. Decision is made by the algorithms. So the deep learning algorithms or AI, and sensor fusion for making the decision as well as the prediction. Whether we have to have a latitude control or long control, whether whether the object is human, or whether it is a traffic sign, or is there any object, or is there any car. So likewise, the decision will be made by the algorithms. So what is the need for the artificial intelligence? So the level 5 autonomous cars, they need to understand and perceive the data as objects in the environment. So this need to be, that also to be done in the real time. So because even a second of latency, that is, if it is not the artificial intelligence, it does not make any sense of the right decision, then it will create the unsafe situation. So there is a need for perceptive artificial intelligence. So once the autonomous vehicle it perceives its surroundings, then it can need to make decisions. So that every possible decision it will be validated to ensure safety. So the automotive simulative solutions it is provided by the softwares. So what for the softwares? What are the softwares to be used? So the softwares it will be used for the EV fleet management, virtual prototypes of EVs, digital cockpit, intelligent mobility solutions, and software for self-driving cars. So there are these are the different stages of softwares to be used in the electric vehicles. So what is EV fleet management? So the EV fleet management software it is used to manage the EV fleets in real-time charging reports and then integration with the cloud and maintenance and support, optimized usage and improve customer satisfaction. So when we are seeing about the virtual prototypes of EVs, these software help to simulate the complex electromechanical components and the interaction between the software and hardware pieces. So we are seeing about the digital cockpit. It provides all digital dashboard system. It can replace the old steering wheels and gearboxes. Then intelligent mobility solutions. So when we are adding the digitalization to any machine, it becomes a connected device essentially. And along with the IoT, it can be further exploited to create an optimized and personalized user experience. So for in case of self-driving cars, so AI self-driving cars should be used. That is the companies like Google and Tesla, they are using the AI for the self-driving cars. So it is these softwares are continuously they are improving. Apart from this, we have to use the software for a motor design, for the powertrain component, and for optimizing the performance of the converters, then powertrain, batteries. So several softwares has to be used in an electric vehicle to make a safe operation. So this is about the ADAS. So how to make a decision path when there is several obstacles. So that should be done by the advanced driver assistance systems. So this will be done by the simulations because we cannot have a test in the real world because it will be very it results in the high cost. So in order to avoid the complexity and high cost, that simulation will be done in the via real world experience will be done via simulation. So through the simulation, we can explore many things. That is, we can have many advancements in the technologies because when we are simply replicating the real world, then we can have many data and as well as the many experiences when we are using the simulation. So these are the electric vehicles which is going to be available by the year 2050. So the electric vehicles will be available in land, sea, as well as in air. So they are using the nowadays they are many of them they are talking about the hyperloops. So the advancements in technologies it is taking the EV in different aspects and also in different modes of transport. So what are the opportunities in EV industries? So in manufacturing and assembly, and research and development area, battery technology area, electric vehicle design area, charging infrastructure area, sales and marketing, and after sales services. So in these systems, many job opportunities are available. It should be known to the students so that they will be interested in EV and that there is a lot of much more to explore technologies in the. Thank you, sir. Thank you all for hearing my lecture with patience.
Thank you.
Sir, thanks a lot.
Thank you, Engineer Aruna, madam.
Thank
It is
you, sir.
very highly informative and technology talk. For recent advancement, electrical vehicle, what are the parts are covered, very useful, and what is the future technology going to come also, you are clearly mentioned. And in the trends, which is the trends going on, the Octopus and automated mobility, which is going to come, that also you clearly explained what are the stages are available, and autonomous driving, how it will be useful, and job opportunities in that electrical vehicle industries also clearly mentioned. Thank you, madam. Thank you. We
Thank you.
move on to, thank you, madam.
Thank you.
We move on to the next speaker, Mr. Sivaram, Engineer Sivaram. I
Yes,
can
sir.
give one, Sivaram, sir.
Yes, sir. Yes, sir. I'm there, sir. Yes. Good evening,
Small introduction before I hand over to mic to next speaker. Small introduction. Engineer Sivaram, he has completed BE Mechanical Engineering, Arulmigu Meenachi Amman College of Engineering, Kanchipuram in 2012, and he did master degree in Regional Center of Anna University, Tirunelveli at 2014, and he is doing PhD right now. And a working experience, he is having more than 8 years working experience in mechanical engineering as a assistant professor. He handled almost all the mechanical engineering subject, starting from thermodynamics to refrigeration, air conditioning, and he scored some awards and recognitions also. Best oral presentation in Anna University, Chennai, 2nd March 2019, and best paper award is got March 2020. In the best paper presentation, in the first prize, he got Ujavaran 2022, held in IGKR Kalpakam on 10th March 2020, and he is a list of papers submitted in the journals, nearly 32 he has had, the national, international journals. And he published one book also, Proceedings of the Second State Level Technical Symposium, BDL 16, which is held in 2017. And he is a book also he has made in 2020, Emerging Engineering Research Technology. Also, he has attended for 7 numbers, and he attended and published international conferences, 12 numbers, 12 international conference publication he made, and a lot of seminars and conferences he has arranged. With this small introduction, I hand over the mic to Engineer Sivaram. He is also working as a Deputy Director, Center for Curriculum Development in AMIT. So by this introduction, I hand over the mic to Mr. Sivaram.
Thank you, sir. Thank you for
Yes,
the
sir.
introduction.
Please.
Sir, yes, I'll just share my screen, sir.
Yes, sir.
Sir, is my screen is it visible, sir?
Visible, sir.
Myself, I'm A.R. Shivaram, Deputy Director, Center for Curriculum Development, and I'm faculty. I'm also a faculty, Department of Mechanical Engineering, AMIT, Chennai. So, firstly, I would like to thank Chairman, Institution of Engineers, Kalpakam Local Chapter, Mr. M. Shanmugasundaram, sir, and our Honorable Vice Chancellor of AMIT, and management of AMET for providing me an opportunity to address in a forum like this. So the title of my talk for today is an overview of VCR system, that is vapor compression refrigeration system and refrigerants. So refrigeration system has become an integral part in our day-to-day life, and it is used in a wide range of applications, ranging from domestic applications to industrial applications to commercial applications, as well as to medical applications. So in our today's talk, we'll just see an outline of a vapor compression refrigeration system and the components that are present in a vapor compression refrigeration system and its types, and which type of component is used for which application, and detailed overview of refrigerants. So what refrigerants were used earlier, currently what refrigerant do we use in refrigeration systems. So with this short note, I'll just proceed further. So generally, refrigeration is nothing but it is a removal of heat, and it is a process by which a particular material or a particular space is maintained at a lower temperature than the temperature of outer ambience or surroundings. So generally, by using refrigeration, the temperature of any enclosed space is maintained at a temperature that is lower than the outer ambience temperature. So a few examples of refrigeration systems are vapor compression refrigeration system, vapor absorption refrigeration system, and thermoelectric refrigeration system, and so on. So in this, almost for 90% of our practical applications, we go with vapor compression refrigeration system. As the name implies, it has a compressor present in it. So that is why it is called as a vapor compression refrigeration system, shortly denoted as VCR system. So this is this is an outline of a vapor compression refrigeration system that has the following components. Normally, a vapor compression refrigeration system has four major components. Firstly, a compressor, a condenser, and a metering device which controls the flow of refrigerant, and an evaporator. So normally, in a compressor, the working fluid that is used in the system, that is nothing but a refrigerant that gets compressed in a compressor, and the compressed refrigerant leaves at high pressure and high temperature to a condenser. And in the condenser, as the name implies, the refrigerant undergoes condensation from vapor to liquid, and the high pressure liquid then enters inside the metering device and it undergoes expansion. That temperature and pressure gets reduced, and finally it extracts the heat in the indoor unit, that is nothing but the evaporator, and again it enters the compressor as a vapor, and the cyclic process continues on again and again. So now we'll just see what happens detailedly in what happens in this components, what is the functioning of these components, and what actually happens in these components in detail. So these are all the four components in any VCR system: a compressor, a condenser, a metering device, and an evaporator. And the working fluid used in the system is nothing but that is a refrigerant. So compressor, so the main component in any vapor compression refrigeration system is nothing but that is the compressor. So without the functioning of compressor, you will not get any refrigeration effect or cooling effect in any refrigeration system. And this compressor provides the work input, due to which energy gets transferred from an enclosed space to an open space. That is, when you provide work as an input, it is possible to transfer energy from a low temperature surface to a high temperature surface. So coming to the functioning of compressor, refrigerant enters the compressor as a low pressure vapor. It undergoes compression and it gets compressed inside a compressor, and it leaves as a high pressure, high temperature superheated vapor. So the working fluid refrigerant, when it is entering the compressor, it should be in vapor state, because a compressor cannot compress a liquid. If so, if a refrigerant enters the compressor in liquid state, it is likely to cause liquid sludging and failure of compressor. So refrigerant should enter the compressor generally as a low pressure vapor, and after compression, it will leave as a high pressure, high temperature superheated vapor. And these are all the two switches that are normally present in compressor, that are present at compressor inlet and outlet. So low pressure safety cutoff switch and high pressure safety cutoff switch. Low pressure safety cutoff switch is normally situated at suction line, that is at compressor inlet line. So when suction pressure drops beyond a certain range, normally there won't be any circulation of refrigerant, or the working fluid present, that is the refrigerant present in the system, may not be sufficient to get the sufficient cooling effect. So generally, when suction pressure drops beyond a certain range, the low pressure safety cutoff switch cuts off the compressor, that is strips off the compressor or stops the compressor. So generally, when there is a possibility of low pressure, when there is a possibility of low suction pressure is, then the level of refrigerant is less. So we would have seen on one fine day, we will be giving a cooling effect of, we will be giving an indoor unit temperature of 20 degrees Celsius in a room. But the air conditioning system, after it has run for a half an hour span of time, may not give the desired input that we gave, that is 20 degrees Celsius. So that may be due to low level of refrigerant, and low level of refrigerant, that is a low volume or low level of refrigerant in the system, can result in low suction pressure. Apart from this, a block in suction valve may also cause low suction pressure. Coming to the next switch, that is high pressure safety cutoff switch, that is present at the discharge line of the compressor, that is on the compressor outlet line. And normally any compressor has a maximum pressure limit that it can withstand. So once we cross the maximum pressure limit, the compressor is likely to explode. So high pressure safety cutoff switch protects the compressor against very high discharge pressure. Normally, high pressure safety cutoff switch is set at 90% of peak pressure that the compressor can withstand. So once the real-time discharge pressure that it reaches 90% of peak pressure, high pressure safety cutoff switch trips off or cuts off the compressor, thereby protecting the compressor from getting damaged. So, possible causes for abnormal rise in discharge pressure is nothing but it is improper condensation. That is, when condenser is normally not functioning, that can result in abnormal rise in discharge pressure, which can result in tripping of compressor. So we would have seen in split type air conditioning systems, which has two units. One is indoor unit, that is the evaporator part, and the next one is the outdoor unit, which has compressor and condenser. So that has an air-cooled condenser. Normally, split type air conditioning systems in the outdoor unit, they employ an air-cooled condenser. The fan that is present in the air-cooled condenser normally provides the air. In case if the fan present in the condenser is not rotating or not working, so we will not get liquid refrigerant at condenser outlet, and we will not see any inference or any inference of malfunctioning in the condenser. Instead, what is likely to happen is discharge pressure or compressor outlet pressure will abnormally increase, which can result in the tripping of the compressor. That is HP cutoff switch, high pressure safety cutoff switch on abnormal rise in discharge pressure will trip off the compressor. So improper working of condenser is one of the reasons for abnormal rise in discharge pressure, or excessive quantity of charging. That is, the refrigerant, if it is charged more than the required level, that could also result in abnormal rise in discharge pressure. So these are all the two switches. One switch, LP, which is present at compressor inlet, and HP, which is present at compressor outlet. So these are all the two switches, LP cutoff switch, that is low pressure safety cutoff switch, and high pressure safety cutoff switch. So coming to condenser, as the name implies, the high pressure, high temperature refrigerant, that is the high pressure, high temperature superheated refrigerant vapor enters this condenser. So here we employ a cooling medium. The cooling medium can either be air or either be water. So by you employing the cooling medium in this condenser, the refrigerant is condensed from vapor state to liquid state. But since there is no change in cross-sectional area of the tube, there is no considerable change in pressure. The high pressure, high temperature superheated vapor, which enters this condenser, undergoes condensation and leaves out as a liquid refrigerant. And at condenser outlet, there is a possibility of getting subcooled refrigerant. That is, when it is condensed beyond its saturation temperature, it attains subcooled state. Generally, subcooling increases the performance of any refrigeration system. That is, subcooling will increase the coefficient of performance of any vapor compression refrigeration system. So the high pressure liquid refrigerant from condenser leaves and it enters inside a receiver tank. So receiver tank is nothing but followed by condenser there is a temporary storage tank for storing liquid refrigerant. That is, it stores the liquid refrigerant temporarily. It receives the liquid refrigerant temporarily from the condenser, and then it transports it to the metering device. So followed by receiver, there is a metering device. So metering device is nothing but it controls the flow of refrigerant. That is the flow of refrigerant which it is entering the evaporator. Normally, depending upon the cooling load in the indoor unit, thermostatic expansion valve is given here for example. So normally, depending upon the variations in cooling load in the indoor unit, that is the amount of heat that needs to be removed from the indoor unit, this metering device alters or changes the pressure of refrigerant or flow of refrigerant. So and apart from this, due to sudden expansion in a metering device, the high pressure liquid refrigerant which enters this metering device, it undergoes expansion. Due to sudden expansion, the refrigerant, it leaves as a low pressure, low temperature liquid vapor mixture. And usually filter dryer will be present before expansion valve. So the reason for having this filter dryer is filter dryer will be present in between receiver and expansion valve. Filter dryer is located before expansion valve. So the main function of this component, it is used to filter out the moisture content present in the refrigerant. So generally, it will be having a liquid desiccant inside it. So desiccants are nothing but they are substances which can hold 27 to 28% of its weight by moisture content or water vapor content. So normally in domestic and commercial systems, silica gel is used as a desiccant, and the silica gel will be present inside this filter dryer, and it absorbs the moisture content present in the refrigerant, and refrigerant which is moisture free leads to the expansion valve. The reason for having this filter dryer is the temperature at expansion valve outlet, maybe for some systems, for domestic systems, it can be 1 degree or 0 degree. At 0 degree Celsius, water, in case water vapor content or moisture content, that will freeze into ice. And that ice which is formed inside this expansion valve will obstruct the flow of refrigerant. So before the refrigerant enters this expansion valve or metering device, this filter dryer removes the moisture content or water vapor content. If filter dryer is not functioning, it will result in the ice formation inside the expansion valve. It may cause a block in expansion valve and it may obstruct the flow of refrigerant. So under such circumstances, in order to remove moisture content, the expansion valve has to be removed and the entire refrigerant has to be evacuated. Coming to moisture indicator. So at filter dryer outlet, there will be a moisture indicator. Of course, this is present in commercial systems. This moisture indicator indicates if the filter dryer has removed entire amount of moisture or not. So in case if the moisture indicator indicates there is a presence of moisture, then a filter dryer needs to be replaced, or the desiccant present inside the filter dryer needs to be replaced. Here, the green color indicates the refrigerant is free from moisture. It is completely dry. And yellow color, it actually indicates that there is a moisture content or water vapor content that is present in the refrigerant. Filter dryer has not completely removed it. Coming to the next part, that is nothing but evaporator. So the low pressure, low temperature refrigerant, then it enters inside the evaporator. And what happens is the enclosed space or the indoor space where heat needs to be removed, that will be at a higher temperature. Refrigerant, it enters this evaporator as a low temperature, low pressure vapor. So naturally what will happen is heat transfer will take place from high temperature to low temperature. That is from the room to the refrigerant that is flowing across the tubes, as a result of which the room temperature reduces and we get cooling effect or refrigeration effect, and refrigerant becomes a vapor, and then it enters inside the compressor for a cyclic process, and the cyclic process continues on again and again. And accumulator, this is nothing but there is a component, this accumulator is situated in between evaporator outlet and compressor inlet. The main function of this accumulator is, in case if liquid refrigerant enters inside compressor, it will cause liquid sludging of compressor, which will result in the failure of compressor. In order to avoid that, accumulator is placed in between evaporator outlet and compressor inlet, and this accumulator accumulates the liquid refrigerant, and feeds to that only vapor enters inside the compressor, and liquid is accumulated within this accumulator, and it is recycled back to evaporator inlet. Next, coming to types of compressors. So compression in a compressor, followed by condensation, followed by a receiver tank, followed by a filter dryer and moisture indicator, followed by a metering device, and followed by evaporator, and followed by an accumulator. And this is the cyclic process which takes place in any vapor compression refrigeration system. Next, we will just see a detailed outline of different types of vapor compression refrigeration system components, that is VCR system components. Compressors, so normally based upon design and working principle, refrigeration compressors can be classified into 5 types: reciprocating, rotary, centrifugal, screw, and scroll. Out of this, reciprocating type compressors, normally these types of compressors are preferred for applications which require high discharge pressure, and normally this has 2 strokes. I mean, the working of reciprocating type compressor has 2 strokes. During suction, when the piston moves from top dead center to bottom dead center, refrigerant enters in, and the refrigerant gets compressed in the compressor, and it leaves during the discharge stroke at high pressure and high temperature. This is usually preferred for applications where there is a high requirement of discharge pressure, and here it requires proper lubrication, because or else due to friction the compressor may get damaged, and since it delivers high refrigerant at high discharge pressure, the power consumption is comparatively high. Now, reciprocating type compressors are not used for domestic systems, rather it is preferred for commercial and industrial refrigeration systems, as well as for marine refrigeration systems. Rotary compressor, this has a rotor present in it. Normally, rotary type compressors are preferred for refrigeration systems with low refrigeration capacity. Normally, rotary type compressors, that is rotary compressors, which is of hermetic type or closed type, is preferred for domestic fridge, that is domestic refrigerators and domestic air conditioners. So these type of compressors are preferred where there is a requirement of moderate discharge pressure or low discharge pressure. So power consumption is very less in rotary type compressor. Coming to centrifugal compressor, which has a impeller and vane arrangement, which is enclosed inside a diffuser. The working fluid enters via inlet, it gets compressed due to centrifugal force, and it leaves via the outlet. Normally, centrifugal compressors may not require internal lubrication, and they are usually preferred for large air conditioning systems. Screw type compressors. So screw type compressors has 2 meshed rotors. Normally, refrigerant, which I mean, among the 2 meshed rotors, one rotor is connected to the motor present in compressor. The motor powers the meshed rotor, and the refrigerant gets compressed between 2 meshed rotors, and it leaves at comparatively high discharge pressure. This is more suitable for commercial refrigeration systems as well as industrial refrigeration systems, and this is mostly used in food industries. Coming to the next type, sprawl type of compressor. Out of all the 5 types of compressors, this has the best efficiency, and this normally has 2 helices. One helix will be a fixed one, and another helix will be a movable one. The fixed helix is fixed, and the movable helix is connected to the motor present in compressor. So obviously, what will happen is there is a shaft which connects the motor and the movable helix. So the movable helix undergoes rotary motion, and refrigerant gets compressed between the movable helix and the open helix, and it leaves at high discharge pressure. Since there are very few movable parts, the noise level as well as the vibration that occurs in sprawl compressors is very less when compared with other compressors which are piston. This is more suitable for industrial and commercial refrigeration systems. Apart from this, compressors based upon location of motor can also be classified as hermetic. Hermetic is nothing but they are closed type compressors. So the rotary compressors which we employ for domestic fridge and AC are actually hermetic type, which is completely closed type. But the drawback of hermetic type compressors is if there is a problem with the motor, there is only option of replacing those compressors, because opening the seal and repairing it, it makes the process more complex. So generally, when a problem occurs in hermetic type compressors, normally we go for replacement rather than repairing it. And semi-hermetic type compressors, which is semi-hermetic, and the next one is open type compressors. Condensers, normally there are three types of condensers: air-cooled condenser, water-cooled condenser, and evaporative condenser. Air-cooled condenser is further classified into two types: natural convection air-cooled condenser and forced convection air-cooled condenser. So natural convection air-cooled condenser uses atmospheric air, which can be found at the backside of refrigerators. So since refrigeration capacity is quite less, or the refrigeration capacity, the overall capacity of the system is quite less, it uses atmospheric air to condense the refrigerant from vapor state to liquid state. And here, in case of forced convection air-cooled condensers, we employ a fan to force the air, and the air condenses as the air strikes the outer surface of copper tube. It takes the heat and refrigerant condenses from vapor to liquid state, normally used in split type air conditioning systems and in quite a few industrial refrigeration systems. And coming to water cooled condenser, it is of normally three types: shell and coil, tube in tube. Shell and coil is preferred till 50 tons. And out of this shell and coil, this has one single shell and tube. Usually water flows inside the tube and refrigerant flows inside the shell, and tube in tube, where refrigerant flows in one tube and water flows in other tube. The last one is shell and tube condenser. For very large refrigeration systems and for commercial and industrial refrigeration systems, shell and tube condensers are employed. Even for marine applications, shell and tube water cooled condenser is employed in accommodation part. So earlier they were using seawater, but since seawater causes corrosion, nowadays they are using fresh water in shell and tube condenser. This can be used from 50 tons to 500 tons of. So for systems with very high refrigeration capacity, shell and tube water cooled condenser can be employed. Evaporative condensers actually both uses air and water. Coming to expansion device, this is thermostatic expansion valve. So thermostatic expansion valve alters the mass flow rate of refrigerant depending upon the changes made in the indoor unit. Say one person is present in a room, 40 persons are present in a room. If 40 persons are present in a room, obviously the cooling load is more. If one person is present in a room, obviously cooling load is less. So with respect to the changes in cooling load, thermostatic expansion valve alters the mass flow rate of refrigerant. Apart from this, this has a sensing bulb. So normally, the sensing bulb of thermostatic expansion valve is situated at evaporator outlet. That is, you can see an evaporator. Sensing bulb outlet has a, evaporator outlet has a sensing bulb. Thermostatic expansion valve sensing bulb is situated at evaporator outlet, and this sensing bulb sees to that always refrigerant leaves the evaporator as a vapor, so that no liquid enters inside compressor. In case if liquid is leaving the evaporator, of course accumulator will accumulate it. But apart from that, once there is a possibility of liquid refrigerant at evaporator outlet, this thermostatic expansion valve alters the mass flow rate of refrigerant or reduces the mass flow rate of refrigerant accordingly. And the capillary tube, usually capillary tube, always the expansion takes place at the same rate because the cross-sectional area of the tube is uniform. So normally capillary tube is used in refrigerators and of course in air conditioning systems till 2 tons. Solenoid valve, in case of large refrigeration systems, we employ solenoid valve. Even reefer containers that are used in marine refrigeration systems employ a combination of thermostatic expansion valve and solenoid valve. That is, 2 expansion devices are used in normally any reefer containers. That is a refrigerated container which is used to transport temperature sensitive cargo from one place to other place. That employs 2 expansion devices, that is thermostatic expansion valve and solenoid valve. And coming to the types of evaporator, bare tube evaporators, which are used in freezers, plate type evaporators. Normally the tubes are embedded in a plate, and this is used for most of the applications, and finned tube evaporators and shell and tube evaporators, which is used for very high capacity refrigeration systems. So next, I'll just give an overview on refrigerants and its types. So normally the working fluid that is used in any vapor compression refrigeration system, that is refrigerant. It extracts the heat from one place and transfers the heat to other place. That is, normally it extracts the heat from indoor space and transfers the heat to outdoor space. And in this process, it undergoes a phase change. That is, in a condenser, it undergoes a phase change from vapor to liquid, and in an evaporator, it undergoes a phase change from conversely, that is from liquid to vapor as it takes the heat. Normally, there are two types of refrigerants, primary refrigerants and secondary refrigerants. So refrigeration systems like domestic refrigerator, domestic fridges or domestic air conditioning systems employ only one primary refrigerant, that is one main refrigerant. But there are systems where refrigerant needs to be transported to very long distance. So on such places, instead of one refrigerant, we employ two refrigerants. That is, the primary refrigerant first cools the secondary, which is a liquid refrigerant. The secondary will be then pumped by means of a pump to the place where, where heat needs to be removed. So what is the advantage in employing primary and secondary together in an indirect expansion refrigeration system? The need for transporting primary refrigerant, we can avoid it because primary refrigerant leakage, of course, it is not economical, and moreover, secondary refrigerants are cheaper in nature. So generally, direct expansion refrigeration systems, that is, let it be domestic fridge or domestic AC, they employ only one refrigerant. They are direct expansion refrigeration systems. And indirect expansion refrigeration systems employ primary refrigerants and secondary refrigerants. Most commonly used secondary refrigerants are brine solution and calcium chloride solution. This indirect expansion refrigeration system is normally used in milk chiller plants. Next, coming to different types of primary refrigerants. Freon family of refrigerants, almost 80% of refrigerants which we use in our day-to-day life, ranging from domestic to commercial refrigerants, belong to this Freon family of refrigerants. This is the first type, and second type is natural refrigerants, and third type is hydrocarbon refrigerants. Of course, hydrocarbon refrigerants have a lot of advantages, ranging from zero ozone depletion potential to very less global warming potential. But since it possesses the risk of flammability, that has not been commercialized to a large scale. And the last one is nothing but isotropic mixture of refrigerants, which is not a single refrigerant, but it is a mixture of two or more refrigerants. Freon family of refrigerants. Actually, Freon family of refrigerants has three categories. First type, chlorofluorocarbon. When considering any refrigerant in environmental point of view, two things are considered. One is ODP, ozone depletion potential, and next one is global warming potential. So coming to CFCs, they have high ozone depletion potential. So according to Montreal norms, CFCs are banned completely. So because they have high ozone depletion potential, and right now we are not using any CFCs. And typical examples of CFCs are R11, R12, and R13. The next family of refrigerant is nothing but hydrochlorofluorocarbon refrigerant, shortly denoted as HCFCs. These type of refrigerant, of course, it is banned in developed nations, but developing nations are allowed to use till the year 2030. This also has ozone depletion potential. This does not have zero ozone depletion potential. HFCs have ozone depletion potential. Now, gradually, HCFCs are phasing out, and they are being replaced by HFCs even in developing nations. A typical example is the phasing out of R22 and replacing R22 by R134A. And the last one, almost for 90% of our practical applications right now at present, we use HFCs, hydrofluorocarbon refrigerants. They have zero ozone depletion potential, and they also have comparatively less global warming potential when compared to the other two types. And R134A, almost in all refrigeration systems, ranging from domestic fridge to commercial refrigeration systems, we can find R134A, and R143A, R152A, and R410A. Almost in all domestic air conditioning systems at present, we can find R410A, and R404A, it is used in marine refrigeration systems. This particular family of hydrofluorocarbon refrigerants, they have zero ozone depletion potential. And in this table, we can clearly see HCFCs have ozone depletion potential of the order of 0.005, and HFCs have a ozone depletion potential of 0. Even natural refrigerants have a ozone depletion potential of 0. And coming to color code. So for the identification of refrigerant, in order to differentiate one refrigerant from other refrigerant, color code has been introduced. And for the purpose of color code, AHRI, that is American Heating and Refrigeration Institute, classifies refrigerants or 4 classes: class 1, class 2, class 3, and class 4, which are nothing but liquid refrigerants, low pressure refrigerants, high pressure refrigerants, and flammable refrigerants. So normally liquid refrigerants, the boiling point is greater than 20. Low pressure refrigerants, the cylinder pressure does not exceed 3447, and the high pressure cylinder pressure exceeds 3447 kilopascal, and the last one is flammable. And I have highlighted a color code for a few important refrigerants. R134A, the color code is light blue in color. R404A, that is used in marine refrigeration systems in large scale, which is orange in color. R407C is in brown color. R410A, which is used in domestic air conditioning systems in large scale, the color code for it is in rose color. Changes in color code. So till the year 2020, the whole of the refrigerant cylinder was painted with the color of refrigerant. And in order to avoid painting complications and disposal of cylinders, so AHRI made a change in color code. The cylinders are maintained uniformly in gray color. So this change came into effect in the year 2020, and this was decided in the year 2017. Alternate refrigerants. So carbon dioxide. Carbon dioxide is a very good alternative to R134A and other HFCs, that is hydrofluorocarbon family of refrigerants. And various commercial systems have started using carbon dioxide. It is likely to get commercialized in a large scale in near future. Hydrocarbon refrigerants, so though they have 0 ODP and they exhibit very less global warming potential, since they have the risk of flammability, they have not been commercialized in a large scale. Of course, various researchers are going on to optimize hydrocarbon refrigerants for commercial usage. And coming to charging, evacuation, and leak detection, I'll just give an outline. So charging, normally refrigerant can be charged as a vapor, and the compressor being turned on at, compressor being turned, normally refrigerant can be charged, it is actually compressor inlet, it is not compressor outlet. So refrigerant is charged as a vapor at compressor inlet, and compressor should be turned on, because to ensure a circulation of refrigerant till the system attains an appropriate standing pressure, that is the pressure of the refrigerant inside the system till it reaches the appropriate range, we continue to charge refrigerant at compressor inlet in vapor state. And the compressor refrigerants can, but in case of modern industrial refrigeration systems as well as in marine refrigeration systems, especially nowadays in modern refrigeration systems, refrigerants are charged as a liquid at condenser outlet. There are suitable cylinders which stores refrigerant as a liquid, and suitable hoses which transfers refrigerant as a liquid from the cylinder to the system. And here charging is done at compressor inlet. R134A, it is charged at compressor inlet, with compressor being turned on till the system reaches compressor inlet. Normally, the blue color indicates suction gauge, and the red color indicates the gauge that is present in the discharge side or compressor outlet side. And methods of leak detection. In case a leak occurs in the system, normally domestic refrigeration systems, mechanics normally employ soap bubble method. In case of commercial systems, we rely on electronic leak detector. And suppose if a system has 10 leaks, 20 leaks, or the number of leaks is more, obviously we go with nitrogen leak detection. That is, nitrogen is charged inside the system. It is left for 1 day time. If there is no pressure drop, all leak has been completely arrested. It means that. And in case if there is a pressure drop, it means leak is still present in the system and leak needs to be arrested. Of course, this is used as an overhauling method, nitrogen leak detection testing method, where the system, when the system has more number of leaks. And fluorescent leak detection, fluorescent is sent inside the system, And wherever there is a leak, that you can see the working fluid, there is a change in color. Out of this, soap bubble method and electronic leak detector are widely used in commercial systems. Evacuation. Normally, refrigerant can be evacuated by means of a vacuum pump, and the refrigerant recovery cylinder is present, to which the refrigerant recovered can be stored in a refrigerant recovery cylinder. And the third system, which you see here, it is used for evacuating the refrigerant present in the system and recovering it to the recovery cylinder. So normally they check vacuum before charging refrigerant. That is, they maintain negative pressure for a certain span of time before charging. In case if the negative pressure is maintained, the system is free from leaks. In case if the negative, in case if it is very difficult to sustain negative pressure, it means that the leak is still present in the system, due to which air has leaked inside the system and pressure has increased. So vacuum pump is used for evacuation of refrigerant. And my concluding remarks, I would like to give. Currently, various researchers are going on with hydrocarbon refrigerants to commercialize it. And apart from that, various researchers are also going on with nano refrigerants and nano lubricants that are employed in vapor compression refrigeration system. So with this, I'll just end my session. Thank you, one and all.
Thank you, Sivaram sir.
Yes, sir. Thank you, sir.
Thank you, Jairam sir. It is a highly, Sivaram sir, there is a highly informative and very lively technical talk, because most of the simulation modules you are demonstrated is very, very useful to understand the concept and understand the technology which we are going to utilize in the refrigeration system, and what is the future technology evolving in this also you are clearly explained, and what are the ozone depletion avoiding refrigeration techniques we are used also you are clearly explained. Based on this talk, we are enriching our knowledge more and more. Thank you. Thank you, sir. Thank you for your.
Thank you, sir.
I'm Mohan Raj from Kalpakam, sir. Excellent
yes,
presentation, Sivaraman, sir. It was covered excellent basics. It was very much nice presentation.
Thank you, sir.
Any questions, please? Audience, any questions? No question?
I have